So hello everyone, how are you guys? कैसे हैं आप लोग? I hope am I audible and visible to everyone. So hello everyone, how are you guys? कैसे हैं आप लोग? I hope am I audible and visible to everyone. Okay, and please confirm that my voice is like audible to all of you. It's not like that you're not getting my voice. Okay. So guys, before starting the class, let me clear you one thing, which again, this is a kind of information which we are giving you. So you can download the Oliveboard app from a Play Store. There you can just open the app and you can download the PDF of the class. As I also share the PDF in my Telegram channel itself. So guys, you can go for banking exams, by subject and by faculty. You can see there. Okay. So you can see the section where the YouTube class PDF is also mentioned, and you can also give a take a test, attend a live class, buy a course, personalized mentorship, and free zone as well. Our best courses, guys, banking super elite all courses are the is basically the best course where you'll get all the mock test and notes. Okay. Secondly, because it's high time, everyone, it's a high time that we are starting. We have done the foundations almost. We have done the foundations and just we are moving towards the advanced batch. It's a high time. So that's why we Oliveboard SBI launched, means this is basically our course. So we have launched the course, which is SBI PO advanced batch. Level up your preparation, everyone. In this you'll get like 100 plus live sessions, advanced prep for men's and mock test plus AI analysis, and GA plus descriptive prep also. This whole course will be in English language. The quality should be like best in the market. Means the quality of the question will be the best. Okay, this you should be clear that quality of question will be the best. Okay, so these are the teachers you can whom the teacher who will guide you. I will be teaching you dealing up with the quant. Okay. So this is the, like I would say, means if you are eager for like going for preparation for the advanced, you can join our course, and this is basically starting on 17th of March. So this is basically starting date is 17th of March. So you all can join me here. Now second point is very important, which is let me make you clear. The point is that guys, if you have watched my yesterday class, we have done how to figure it out the square. Okay, so we have done the techniques of square, we have done the techniques of cube. Okay, somehow the cube is left, so I'll discuss today that how to figure it out the cube. Basically the point is how to find out the cubes. Okay, how to find out the cube. This we will be discussing as well. And agenda, basically the agenda is that we have done the squares. I have guided you the base rule also, which starts from 25 to 75, and which also starts from 75 to 125. Okay, these are the base rules. Okay, now secondly, I would say we will be revising this also. Give me a moment, I'll revise this for you. And the cubes also we will be revising. Now the very important topic that student is having a lot of like confusion in that, which is a square root. Okay, which is a square root. And see, basically let us focus on this part. I'll start discussing the cube, square and everything, but let us discuss about the square root. Okay. This topic you guys need to understand. So everyone need to understand this topic, that how to differentiate between the square root. So basically two terms are coined. Okay, one is a perfect square root and other sorry, in square root basically two terms are coined. If I would write now, in square root basically two terms are coined. First I would say the perfect square root. Okay, first is perfect square root. You just listen everyone, because I'll give you the notes in the Telegram. So just first of all, listen that what I'm saying and try to understand, okay? Because some of you have a lot of confusion in this, so I'm just clearing that part. So, one is that perfect square, okay? So perfect square, you need to find out the square root, and the other is non-perfect square. Other is non-perfect square. So basically, everyone needs to understand that what are non-perfect square. How will you figure it out? Okay, the number is having this number is sir non-perfect square. Okay, you need to figure it out this. Okay, so how to figure it out that number is non-perfect square? Okay, or number is non-perfect square. So how can you figure it out? See, to figuring it out, you need to watch at unit place, where you need to watch a unit place, bachcho. If you watch the unit place having digit what? Having digit 2, 3, 7, 8. Having digit first is 2, then is 3, then is 7, and then is 8. Now you will say, sir, how to remember this? Remember only two number. Other number is making sum 10. Okay. Remember only two number. Other number is making the sum 10. For example, if you remember 2, what you will add that this end up to 10. So you will say 8. Just remember 3. What you will add up to this number to get what? To get 10. So you will say 7. So any number in this world which ends with 2, 3, 7, 8 is called non-perfect square. First of all, now you can ask, sir, what is the square of, let's say, any number, but you should be very clear that number is perfect square or not. Means that number is perfectly squared or not. Because see, if I say that 4 ka square is 16, okay, so this is a perfect square, but you cannot write now that suppose if somebody says 17, under root of 17 cannot be the 4. This number is basically non-perfect square. So for this case, I am saying the unit place should, see, 17 is coming now. Why? Because the unit place contains either 2, either 3, either 7, either 8. This should be clear to everyone in the class. Fine. Always remember, everyone, that whenever I talk about non-perfect square, the unit place of that number let me just say you, the unit place of that number should contain either 2, either 3, either 7, either 8. Always. This is 100% true. This is 100% true, guys. This is 100% true. Either 3, either 7, either 8. Unit place should be either 7, either 3, either 8. Okay. Now, perfect square is what? So let us have a discussion. I'll discuss all the part, but let's have a discussion on this. What is perfect square? Okay. I hope my voice is like audible to everyone. Please confirm my voice is audible to everyone. Now you're getting my voice. Okay. So let's talk about perfect square. Okay. So whenever I talk about perfect square, what is perfect square? Means a perfect square is that number, the unit place of that number will not end up with 2, 3, 7 and 8. Correct? No. The unit place of that number will not end up in 2, 3 and 7, 8. Correct? So for example, if I say what is 1 ka square, you would say 1 ka square is 1. What is 2 ka square? 2 ka square is basically 4. What is 3 ka square? 3 ka square is basically 9. What is 4 ka square? 4 ka square is basically 16. What is 5 ka square? 5 ka square is basically 25. Correct? No. What is 6 ka square? So 6 ka square is basically 36. What is 7 ka square? 7 ka square is basically 49. What is 8 ka square? 8 ka square is basically 64. What is 9 ka square? So 9 ka square is basically 81. What is 10 ka square? So 10 ka square is basically 100, right? You need to keep in mind, let's try seeing it at what I'm analyzing here. So now the point is that every one of us need to analyze something. Now you see, as I said now, perfect square is that number in which the unit place should not contain 2, 3, 7 and 8. So isn't you seeing that any number is ending in 2, 3, 7, 8? This is ending in 1, this is ending in 4, this is ending in 9, this is 6, this is 5, this is 6, 9, 5, 6, 9, 4, 1 again. So these numbers are not ending in basically 2, 3, 7, 8. So that's why these numbers are called perfect square. Now the point comes, okay. Now the point comes, everyone. Now the point comes, ki, okay sir, fine. But what to analyze here, right? Point comes, point comes, is it visible? No. Everyone is getting my voice, no? Yeah, fine. So the point comes, what to analyze, okay? What to analyze. So what do you want to analyze here, okay? So the point comes here, say sir, what to analyze. So we'll see again, we'll see the unit place, okay? We'll see what? Here also we'll see the unit place. We will see the unit place, okay? Now you'll ask why we are saying it. Just observe, because this is called an analysis, okay? This is again I would say call as analysis. Analysis. There would be something that you can figure it out, okay? So let's see, okay, fine. Let's see. If you're seeing the squares of a number till 10, the unit place of 1 ka square is 1, correct? The unit place of 1 ka square is 1, but the unit place of 9 ka square is also 1, correct, no? So if I say unit place is coming 1, it should be ending in two squares. One is, you are getting 1 ka square, you are also getting 1, 0, 1, and 9 ka square you are also getting like 81, which is a unit place again 1, correct, no? So if anyone is getting 1, they can say either it lies in 1 ka square or either it lies in 9 ka square, fine. Now let's come to the point. 4, let's see 4. Now 4 is also here and 4 is also here, so you can say what? 4 is also here. Now see the observation, everyone. So if I say that there 4 is at the unit place, which two squares contain 4 at the unit place? Which two squares contain 4 at the unit place? Now you will say, first of all 2 ka square, 2 ka square, and then again 8 ka square. These both number contain 4 at the unit place. This both number contain 4 at the unit place. Very, very strong observation. Unit place. Very, very strong observation. Fine, no? Suppose if I say, now let's say go for 9. Is it 9? Yeah. 9 also same rule follows now. If I go for 9, 9 comes at the unit place of 3 ka square and 9 comes at the unit place of 7 ka square. Correct, no? Yeah, fine. Now 5 is 5 only. So basically, can I say we are having 5 is 5 only, na? So we'll not discuss about the 5, because 5 always, if you do a square of 5, that will end up to 5 ka square only. So that's not a big deal. I think this should be understood to everyone. So you can observe now, 1 ka square, 4 ka square, 9 ka square, 5 ka square. These are the strong observation when you do the square root, when you figuring out the square root. These are the strong observation when we try to figure it out the square root, okay? Please keep in mind, whenever we want to figure it out the square root, we should keep in mind these things, okay? I hope you got this. This is very important, okay? Perfect square. We are discussing now again. We are only discussing about the perfect square. We are not discussing anything else. We are discussing about the perfect square. Keeping in mind, we are discussing about the perfect square. Okay, fine. Now let's come to the point. Okay. Now see. Now let's take an example. If I take an example like 4489, under root of 4, 4, 8, 9. I need to find out the square root. I need to find out the square root of this number, okay? How will you figure it out? Let's go with the steps, okay? Everyone, let's go with the steps. If I go with the step number 1. Step number 1. Always remember, you need to bifurcate the 2 digits, okay? You need to bifurcate the 2 digits because you're talking about square, which is a power 2. So always bifurcate the 2 digit. Okay, fine. So you can write down step number 1. Bifurcate bifurcate the last two digit. Always first step is that bifurcate the last two digit. I hope everyone is getting. Bifurcate the last two digit. Okay, am I audible? No. Am I audible? No. Bifurcate the last two digit. Okay, now as we done the as we bifurcated the last two digit, then the second step is what? Second step is basically what? Second step is that just see the unit place. Okay, just see the unit place. Okay, fine. Okay, so let's follow these two steps for this particular question. Now if you bifurcate done, if you're seeing 9, then 9 is common in which two squares? Again, 9 is common in which two squares? 3 ka square. So it would be either 3 ka square or it would be common in either what? It should be common in either 7 ka square. Correct. So basically whatever it is a square of, that unit place either ends in 3 or either ends in 7. That's a guarantee. Whatever this number is basically square of, this number, the number that will end in either 7, either 3 or either 7. This is confirmed now. Now we are fighting for the first digit. Okay. So if you are fighting for the first digit, let's pick up this digit, which is 44. Now if you pick up 44, okay, fine. Now see the nearby squares. So you will say what? You will say, sir, I know that 6 ka square is basically 36. Okay, fine. And 7 ka square is basically 49. Please observe this, everyone. What you observe now, you said that 6 ka square is 36, 7 ka square is 49. Correct, no? Is it fine? Correct, no? Is it fine? I hope you understood. Now always take a smaller number. So it is guaranteed that either it should be 63 or either it should be 67. Always take, step number 3 is always take a smaller number. Step 3 is basically always take a smaller number. Always take smaller number. Always take a smaller number. That's you're taking in. Okay, that's you're taking in, you're taking like smaller number. Fine. Is it clear? Yep. Now see, now the point comes, which one is the square, sir? Is it either 63 or 67? For that you need to check out the difference. Difference means from 44. Now see the logic. From 44, if I write so, from 44 it is the difference and from 49 it is the difference. Okay. Now see the logic is that from 44 to 36 or from 36 to 44, you need to travel 8. Correct? No, because you need to travel 8. In this case, you need to travel 8. And from 44 to 49, you need to travel 5. Okay. So here you are getting which number? Smaller the gap, that number should be, that portion should be the square. So basically the gap less is of 7 ka square. And by default, the answer should be 67, because in this two, which is bigger is 7 ka square. So that's why bigger number should be there. Why bigger number? Because the difference of bigger number from the bigger number is less. So that's why the answer is 67. Now I hope everyone got this. I'll repeat it for you once more. Okay. I repeat this for you. So let me just make you clear how I'm doing it. So everyone needs to understand, guys. Okay. I hope you guys are getting this. And I'll give you the PDF. So do not forget that you will get the PDF. That's a guarantee. Okay. Now see what is basically I have done. I've taken a square of 4489. Okay. First of all, I bifurcated the last two digit, which is 89. I bifurcated this. Okay. Then what happened? I see the unit place, which is 9. So 9 comes in the 3 ka square and 9 comes in the 7 ka square. That is also fine. That is also clear. So my square should be either, the last digit of the square should be either 3 or either 7. That is guarantee. That is guarantee. Either it should be 3 or either it should be 7, not more than that. Okay. Now the second thing comes that what should be the what should be the first digit? Now if we'll now if you'll go for the first digits, then copy the other two digit, which is 44. Now if you see the 44, everybody, 44 is in between. So the square is basically 6 ka square is 36, and then 7 ka square is 49. Compare 44 from 36 and compare 44 from 49. So basically the difference, the portion which contains the difference should be, if that portion is smaller, that should be the answer. If this is bigger, that should be the answer. So basically 36 is basically 8 more, and this is basically 5 more, and the lesser the gap, that should be the part, and which is 72, which is 7 chi square. So that's why 67 should be the answer. The greater one should be the answer. Let me take one more example to make you understand. Okay, let me take one more example. So I hope you will understand from that. So let me go for one more example. So if I take a number like 7921, again this is a perfect square, no? If I take a number, suppose if I take a number 7921, suppose I take a number 7921, steps should be the same, steps should not change. A step should be the same, step should not change. So step is basically not changing. So you need to follow the steps first, okay? Okay, guys. Okay, bifurcate. I have bifurcated this first of all. If I bifurcated this, 1 comes, the last unit place is 1. So 1 comes in 1 ka square, and then 1 comes in 9 ka square. So this is basically 9 ka square is basically 81, and this 1 ka square is basically 01. But I have that guarantee, that this whole number, whatever it is a square of, this whole number, whatever it is a square of, the unit place of that number should contain either 1 or either, I would say, 9. That's a guarantee. That's a guarantee. But this is only for the unit place. This whole thing is done only for the unit place. Okay. Now for the first digit, we need to look for the first digit. Let me, if you want to go for a first digit, so for the first digit, what do you need to do? For first digit, okay, it's getting very harsh. So for the first digit, what I need to do? For the first digit, guys, which is 79, So for the first digit, which is 79, I need to go the nearby square, which is 8 ka square. First is 8 ka square and other is 9 ka square. So can I say that 8 ka square is basically 64, correct? No. And 9 ka square is basically 91, correct? No. Then I need to see the difference. So basically, first of all, I need to take the smaller number. So can I say either it should be 81 or either it should be 89? That is guarantee. Okay. Now to differentiate that which one would be the correct, that is the other process to like check in. So come on. Now I need to go for a difference. So 7964 difference and 7991 difference. I hope everyone is getting this. This is very important, guys. Okay. This is very important. So everyone should get this logic. 73. Okay. Everybody, can you confirm this? Come on. I hope so. 79. So now you can say that 79 plus 1 is what? 80 and 10. 80 and 10. So how much you will plus here? Can you say you will plus how much? You will plus 11. So see, if you plus here 11, this is 9 and 10. No, you will plus there 12. If you will plus there 12, 12 means what? 9, 10, 11. Okay, 11. And then, so this is the difference contains what? 12. Is it exactly the same as I am saying? This contains what? Exactly the same what I am saying? Everyone? Say yes or no? Now 79 and 64. 64 plus 7. So you can say that again, the number are basically, the number is basically bigger one, na? The difference from 64 and 79 should be bigger than 12. So my difference is less of 79 to 91. 91 is the bigger number, so the answer would be the bigger number, which is 89. I hope, I hope you guys are getting my point. Come on, say, I hope you guys are getting my point, everyone. This is the most important thing which everyone should understand. Most important thing, I would say, which you guys need to understand. Let's figuring out other example also, which is, I would say, 6724. Under root of 6724. Okay. So this is basically a number which is under root of 6724. How to figure it out? Now see, first step, bifurcation. Now first you try this, then I'll try. First you try this, okay? First you please try this, then I will try. These are basically, I'm revising for all of you as well, so that you guys can revise these things. Okay, now let's come to the point. So let's come to the point. Okay. What I need to check now? See, when you go for 20, bifurcate, okay? If you're bifurcating, this is 24. Now see the point, if you're bifurcating, this is 24. Now 24, see the unit place, which is 4. 4 it comes between. Now 4 ka square is 16. No, 2 ka square is 4 and 2 and 8. So can I talk about 2 ka square? So can I talk about, this contains basically 2 ka square and 8 ka square. 2 ka square also gives me 0.4 and 8 ka square gives me 64, which is again 4. So it is guaranteed, whatever this is a square of, the last place of that number either contains 4 and the last place of that number, sorry, the last place of this number either contains what? Either contains 2 or either contains 8. That is guarantee. That is sure. Okay, that's a sure part. Now let's come to the first digit. First digit we need to see 67. So if you come 67, now for the 67 you need to watch the nearby squares. Okay, so 6 ka square, 4 ka square, 7 ka square. So you will go for 7 ka square, which is 49. 8 ka square, sorry, you will go for 8 ka square. So you can go for 8 ka square. 8 ka square is basically 64 and 9 ka square is basically 81. Now see, without checking out the difference, take the smaller number. It should be either 88 or either should be 82 or 88. Okay, but as of now you can say that difference for the confirmation part, you can see the difference of this to this is very less. So the smaller number would be my answer, which is 82. So my answer is 82. That's need to be done. That's the only part that we need to do while answering this question. While answering the questions, that only we need to do. Fine, you're getting my point. I hope so. You are getting this. Okay, let's take one more example. Let's take one more example. Is it right? Okay. Now, if I take one more example, let's take one more example, which is 1, 3, 4, 5, 6 under root of 1, 3, 4, 5, and 6. Come on, figure it out. Go fast, everyone. Please solve this. Come on, guys. Please solve this, everybody. Come on, solve fast. Come on, solve. Say 1, 3, 4, 5, 6. Same process will go on. Same process will go on. Same process. Nothing more than that. So what we are doing here? Come on, say. We will be bifurcating these two digits, 56. Okay, fine. 6 comes in, 4 and 6. So the unit place would be either 4 or either 6. That's a confirmed partner. That should be either 4 or either 6. That's fine. Let's come to this 3 digits, which is 134. If you write 134, then you should understand this comes within 11 ka square, which is 121. Then it comes in 12 ka square, which is 144. Okay. So now again you need to compare the difference. You need to compare the difference. Here the difference is of 10. Here the difference is of plus 10. Here the difference is of how much? How much? Huh? How much, guys? Come on, say 13. No, 13. Which one? You need to take a bigger number. First of all, either it should be 114 or either it should be 116. But this gap is less, which is a bigger number. So my answer is 116. Fine. I hope you understood. So this is how you can figure it out, the square root. This is the way how you can figure it out, the square root. Okay. Let's come to the point of non-perfect square. Okay. Now we will be discussing the non-perfect square. Non-perfect square. If I go for non-perfect square, the logic is of Aman mantra. Just you need to keep in mind the Aman mantra, which is what? See. Now, under root of a plus b would be equal to, always remember, would be equal to under root of a plus b upon 2 under root a. Correct. Now, if I go for under root of a minus b equal to under root of a minus b upon 2 under root a. These are the two mantras you should keep in mind while you answer. Now, everybody in their mind having that how to utilize it. Okay. So first of all, let's take a number under root of 87. Okay. First I am taking under root of 87. How to figure it out? The square means nearby, you can say. You cannot say the confirmed part, but you can say the nearby part. Okay. So the nearby part should be how to calculate. First of all, can I write this as a, which is again the keeping in mind, this is should be a basically perfect square. This should be basically under root a is equal to perfect square, always. So can I say this should be under root of 81 plus 7 upon 2 into under root of 81. So I can say this is 9 plus, this is 6, 9 plus 6 upon 2 into 9, correct, which is 9 plus 2 3s are 6, and this is 1 by 3, which is 9.33. Answer would be 9.33. My answer would be clear, no? You're seeing that what we are doing basically the logic of non-perfect square. The logic of non-perfect square. Everyone doesn't understand this part. So that's why I always say that you need to understand that how we are figuring out the question. Everyone. Like everyone should understand that how we are figuring out. We'll take some more example so that I make you clear all the part. Let's take some more example. Suppose I take an example of, let's say I take an example of under root of 144. Yeah. 114. Now see, 1 4 114. 114. The point is that now you will say, sir, you said the perfect square, non-perfect square should always contain 2 3 7 4, 2 3 7 and 8. By seeing also you can observe now this should be non-perfect square. So that number is 100% guarantee, but this is not. By visualization we can also say, okay. So the steps are what? Simple. What you can do? What you can do here? Step should be what? Go to the nearby. So if you'll go to the nearby, you can say under root of 100 plus 14 upon 2 under root of 100. Is it right? Again you can say this would be 10 plus 14 upon 2 into 10. Okay, 2 7s are 14. Fine. This should be 10 upon 7 by 10, which is 10 upon 0.7. Correct. Till now it's clear. So this is basically 10.7. Basically 10.7. I hope this is clear again. How we are figuring out? Please say. I hope this is clear again how we are figuring out. Like we are going, how we are going with the roots, I would say, the non-perfect squares. Okay. Let's take one more example. Can we go for one more example? Let's take a bigger number, which is under root of 1800. Let's take a bigger number, which is under root of Let's take that number under root of 1800. Fine. How we can, come on, try this. How you can try this, come on. Question is under root of 1800. How you can try this? Try fast, everyone. First of all, break out this number in two parts. First is under root of 1600 plus 200 upon 2 upon under root of 1600. This is basically 40 plus 200 upon 2 into 40. 0, 0 cancelled out. 4 5s are 5 by 2, which is 40 plus 2.5, which is 42.5. Correct, no? Process of figuring out the non-perfect square, okay? Clear? Let me come to the cubes. If I come to the cubes, first you need to learn the cubes of a number. For example, 1 ka cube, 2 ka cube, 3 ka cube, 4 ka cube, 5 ka cube, 6 ka cube, 7 ka cube, 8 ka cube, 9 ka cube, and 10 ka cube. 1, 8, 27, 64. Correct? 125, 216, 343. Correct? 512, 729, 123. Okay. These are the cubes. So must remember. These you need to must remember. So how to? Let's say under root of, let's say taking random number, under root of 238, 328, 238, 238, 328. Now see, replacement of 8 is 2 and 2 is 8. Replacement of 8 is 2 and 2 is 8. So for 8, this should be 2. Okay. So for this three digit, you need to see the nearby. So for 238, see the nearby number which belongs to this. So can I say for 238, it should be 6 nearby to 6 ka cube, which is 216. Or you can also say the 7 ka cube, which is 343. Do not take the larger number. Always take this, the nearby number, which is 216. So this is basically cube of 62 ka cube is 238328. Correct, no? Correct, no? So these are like very important facts about the cubes, which you need to keep in mind when you answer the questions. Okay, you need to keep in mind when you answer the questions. Everyone in the class should have clear understanding. Let's take one more example, so the idea should get you clear, make you clear. Okay, under root of 19683. Come on, under root of 19683. This is cube, not cube root of, sorry. Again, this is a cube root of. Cube root of come on, try this. Try fast, everybody. Come on, try this out. Always bifurcate the 3 digits because always bifurcate the 3 digit because this is a cube. This is a cube, so that's why you need to bifurcate the 3 digit. Now 3 for 3, you need to check what? For 3, 3 comes in 7. So guarantee this should be, this part should be 7. Need to check 19. Nearby. Now 3 ka cube is 27. 2 ka cube is 8. Take out this number, which is 8. So this is 2, 27. So 27 ka cube is this one. Understood? I hope so you guys have understood. Fine, no? Everyone. So see, as I said in the today's class, what I said, I'll give you the PDF as well. Do not worry about the PDF. Let me just scan out the PDF also. So guys, as I said earlier, we have completed the square, cube, cube root and square root. So every one of you should practice out more and more problem just for clearing your concepts. Okay. Now this is the most, I would say, confusing part, which every student like figure it out every time they figure it out. Okay, every time they figure it out, they say, sir, sometime I don't get how to see non-perfect square or how to perfect square. So my point is that it's very easy. Okay, I've just compiled all this in two videos, which you can say, which I've discussed: square, cubes, square root, and also I would say cube root, and also a cube root. Correct, no? So as I request all of you to like go through the PDF, which I have shared, like I will be sharing. Give me a moment. I'll just share the PDF. I will be just sharing the PDF to all of you. So whenever you get the PDF, try practicing out. Try to copy, make a notes out of it, because as far as you'll make a note, that would be very good for you. Okay. Till then, if you join my advanced batch, you guys can join my advanced batch. We are like yet we are at the verge of completing the foundation also. So everyone can join that this batch, which is SBIPO advanced batch. Till then, I hope you really enjoyed the class. Do comment out, guys. This is very important for all of you, and I'm giving you homework as well. Like the homework would be, can you give me the answer of what is the cube root of 850? Let's take 850534. Answer me. Till then, bye bye. Take care. Shining off. Agnimitra, keep shining and keep learning. Bye bye, guys. Shining off. Bye bye. Take care.